All right, so here's our first lesson for trig and algebra 2. And so trig and algebra 2, I think everything that we're going to do is based in the unit circle. This is something that a lot of times it looks daunting and crazy, but really if you can count, and I'm not being facetious, if you can count and you can remember how to count, then you should be good at this entire unit because it is almost completely memorization. There's not really a whole lot of process to it. It's just counting and matching. And so the first thing is you need to like memorize this circle, which is how to fill it out. And I'm going to help you with that. There is a lot of information on it, but we'll practice it a lot in class. And then once you have the circle, like I promise you on your test, you're literally just going back and forth matching, looking at the circle and matching like the answer. So there's not really like I said, a lot of thought per se. Okay, so we are going to talk about sine, cosine, tangent at some point, but not in this lesson. As far as geometry goes, everything I'm about to show you comes from geometry, comes from like the 30, 60, 90 triangles and the 45, 45s, those special right triangles. But again, you don't have to know those. The big things that you need to be able to do, and I'm going to show you how to do for this circle, are to count by 45s, and then we need to know how to count by 30s. All right, so first thing, this is a circle, which is like a big round thing, right? And the fact that it's a unit circle just means that the radius of this circle equals 1. So the radius, remember, is that part from the center to the circle itself. So I've got this big circle. This circle that you draw in your notes, honestly, should probably take up about half of your paper. It should be pretty large because you're going to put a lot of information on it. So again, we said the radius of this circle is 1. It is centered at the origin. So we'll talk about that a little bit later, but right now just know that it's centered at the origin. And now let's start counting. So everything you're going to do, you're going to start here on the far right. And remember how when you learned quadrants, now this is like way back for, I don't know, algebra 1, pre-algebra probably. The quadrants are, why is it not writing? All right, there we go. The quadrants are 1, 2, 3, 4. So remember you like start in this top left area, or sorry, top right quadrant, and then you work counterclockwise. So counting this is going to be the same thing. All right, so I'm going to start with, I guess I'll start with 45s. So you're starting here, which is going to be 0 degrees. 45 is halfway between 0 and 90. And I'm just going to continue to count up by 45s. And this is, I happen to have these memorized, but like you don't have to have them memorized. You can literally just keep adding 45 over and over and over again with a calculator if you need to. And so when you get all the way back to the end, this is 0 degrees or it's 360 degrees. And so what you're measuring, I'm going to draw this and then I'm going to erase it. But what you're measuring is an angle that starts here and it either opens however far you say it opens. So like this would be opening 45 degrees, or you can swing it all the way around and open 360 degrees, or 0 or whatever else. All right, good. So you're almost there with angles. So those are my 45s. And now I'm going to do my 30s. So 30 is not quite as far as 45. And if you count it by 30s, you get 30, 60, and now 90 would be the next one, right? So that if you count by both of them, it kind of checks itself out that you've hit all of the things. So this is 30, 60, 90. In each quadrant, you're going to have like 2, so you'll have 3 tick marks all together in each quadrant. So now you're going to count it by 30s. I'm going to pause the video and fill all of that in. All right. So at this point, you should have this circle drawn with all those angle measurements. And I would either, there's kind of a few ways to do this. I would make your notes to yourself. I would either tell yourself to first count by 45s and then count by 30s to get your whole circle. Or I have had people in the past, and I'm not going to write this, but I'm going to show you. I have some people in the past, students have found that it's really helpful for them to just count by 45s first. So all these red marks. And then they notice that for the red marks, if you go 15 in either direction, you hit the other 2, right? So like if you go 15 backwards, that's 120. If you go 15 forwards, that's 150. And that was how they like memorized how to fill out all of these spots. So whatever method works for you, that's fine, but you need to come up with some method that's going to help you remember how to fill in all of those things. All right, so this is for degrees. Now, on yours, you can either do a separate circle or you can do it on the same one. I'm about to do radians, and you may not remember radians, but it's another way to measure angles. And it's okay if you don't remember them because I'm going to show you everything that you need to know for Algebra 2. And I'm going to draw a whole new circle because I don't have enough room on my screen to do them both at once. So you can either draw a new circle or you can just label it all in the same one. Okay, so real quick, so all the way around the circle, if we talk about degrees, is 360. So like if we start here, right, and we move all the way around the circle, that's 360 degrees. The question is, how is that measured in radians? And radians is just a more like accurate way, precise way. You use it a lot if you do pre-cal or higher level math. So radians comes from the fact that the radius of this circle equals 1. And if you're going all the way around the circle, you're going to be measuring the circumference. I don't know if you can hear my baby or not. He's having a moment. All right, so circumference equals pi times diameter, right? So if the radius is 1, that's going to mean that the diameter is 2. So all the way around this circle then is going to be 2 pi, which means if we go all the way around, 360 is the same as 2 pi. And one little note that you may want to make here is to remember the conversion factor between pi and radians. And that conversion factor is that 2 pi radians equals 360. Or you can say pi radians equals 180. And that's just so that it's a little bit simpler to look at. So I would make this note, and then I'm about to show you what the unit circle looks like for radians. Okay, so we're going to kind of start the same way we did with the degrees. We're going to start over here at 0. And I'm also going to make a note that this is 2 pi, because if we go all the way around, that's going to be where that is. On the other side then, only halfway around, it's just going to be pi. Let me draw my little grid here. And then if you go, so just so you remember what I'm saying, I started here. If I went halfway, that's just a single pi. If I go to the top up here, that's going to be half of that. So you can write 1/2 pi, or I'm just going to actually write pi over 2. So each quadrant, 90 degrees, is pi over 2. So this is, I've got here 0, pi over 2, 2 pi over 2, which is just pi, right? 2 halves, which is just a whole. This is 3 pi over 2 down here at the bottom. 3 pi over 2, and then 2 pi on the other side. All right, so now we're going to be counting by fractions, and it's almost easier like if I draw it out for you. So remember that the whole top half of this circle is one whole. So if I cut it like this, and I'm going to highlight so that you can see it a little bit better. If I cut it like this, think about how much of the whole, remembering that the whole is only the top half. So right now I'm ignoring everything down here at the bottom. So how much of that is this piece that I've drawn right here? And hopefully you come up with the fact that that's a fourth, right? 1, 2, 3, 4. So if that's a fourth, then that means right here we are going to write 1/4 pi, or I'm going to write pi over 4. And then here, all right, so notice I'm going to kind of draw these. This is 0 pi over 4, 1/4, 2/4. Think about that. 2/4 is the same as a half. 3/4, so this is 3 pi over 4. 4/4, which is the same as a whole. 5/4, 5/4 pi. 6/4, that's the same as 3 halves. 7/4. And then 8/4 will get you back here to 2 pi because 8 divided by 4 is 2. All right, so next to this circle, I would put a little asterisk, a little star or something, and tell yourself that the first thing you need to do on all of these is count by fourths. Like I would literally write those words, radians, count by fourths. Okay, So now I'm going to use my highlighter again and show you what else we're going to count by. So this time, again, I'm just looking at this top half of the circle up here and counting that as a whole because that's one whole pie. You would be mad if you went to a store and you were like, I want to buy a whole pie, and then they gave you a semicircle because you'd be like, that's not a whole pie. Oh, math jokes. Man, I make myself laugh. All right. So this time we're going to cut it into thirds, or not thirds, sixths. So like there's one, and if I make a line for you just so you can kind of distinguish it, that's 1, 2, 3. All right, so this is 1, 2, 3, 4, 5, 6. All right, so now that we've cut it this way, you should see that each of these tick marks is going to be counting by a sixth. All right, so now we've got 1/6, 2/6, and you can write 2/6, or that's going to reduce to pi over 3. I'm probably going to write the reduced ones, but well, I don't know. I'll write the regular ones, and then you can just go back and reduce them if you need to. All right, so that's 1/6, 2/6, 3/6 is going to be right here, right? 3 over 6 is the same as a half. 4/6, 5/6, 6/6 is going to be right here. That's the same as a whole, 6/6. 7/6, pi, 8/6. Again, that 8 over 6 pi is going to reduce. That's 4/3. 9/6 is down here at the bottom. So these corner points, the top, bottom, like north, south, east, west, they check it themselves because you count them twice for each one. So 8, 9, 10/6, which is the same as 5 pi over 3. And then 11/6. And then again, you'll get back to 12/6, which 12 divided by 6 is 2. You might start to recognize some patterns there with those. Like I have some people that notice that these right here are all odd numbers, right? Like 1, 3, 5, 7. I don't know. The more you work with it, the more you're going to see patterns. So the two things I would write down for yourself for radians are you need to count by, we already said 1/4. So count by fourths. That's going to get you your quarter marks. And then count by sixths. All right, one more just little summary or image for you. Degrees, you can read that. Radians, you can read that. Notice that the red correspond to one another, so 45s and 1/4 both match up. I've color-coded the red ones here. Those are the ones you're counting when we say that. The 30s and the 1/6 match up. And then the blue, those are color coordinating also. And this is just a visual representation that these quadrants, these corner markers, what I was saying, north, south, east, and west here, these get double counted by both. So they should check each other that you have everything counted correctly.